Students, good morning. Students who are in the online, am I audible? Now, we'll start with the next topic, multi-threading. I hope in the last class, come in, come in. So I hope in the last session, you might be practiced the entire pandas level. Practiced it? Practiced or not? Practiced. Boys, only good morning saying and sitting quiet and calm. What boys? Practiced? So let's coming to the index multi-threading. So there I am going to talk about two levels of programming. One is the first level. So let us start with purpose of multi-threading. Purpose of multi-threading. Next term, types of applications. Types of applications in threading. Types of applications in IT, I can say. One is process-based applications. Process-based applications. And come in more. Thread-based applications. Thread-based applications. Okay. Next, we are talking about definition of thread. Definition of thread. Then purpose of thread. Purpose of thread. Okay. Next, we are talking about number of approaches. Number of approaches for developing thread-based applications. Our basic discussion is thread-based application development. Process-based applications. Now we are entering into thread-based application development. Next term, module name for developing. Module name for developing thread-based applications. Thread-based applications. That is what I am taking is only there is one module is available. What is that module name? Threading. Threading. And followed by programming examples. Programming examples. So this is a detailed discussion about threading. Detailed discussion about threading. That is what are the functions available and all those things. This is comes under first level part of it. First level discussion. And the second level discussion is synchronization. Synchronization. It is an operating system level concept. Synchronization concept. Synchronization concept in threading. In threading. Or we can also call it as what you know. Deadlocks in threading. Deadlocks in threading. And next I'm talking about deadlock elimination. Deadlock elimination. Deadlock elimination. And implementation of lock class of threading module for deadlock elimination. Deadlock elimination followed by programming examples. This is what we are going to discuss. This is the index of the threading. Easy, students, not a difficult, but today's class is very important. This will take 3 days. So first today and tomorrow, I'll discuss this part of it. And next we will go for extension to this level. Extension to this level. What is the next implementation? Lock class. This is the index of multi-threading. So let me start. I'll save it. Go to the place, students. 7 a.m. I'll go for threads and go to the place notes. So there I will take it index. So let us start the discussion about multi-threading now. Fine, students. So in information technology, we come across two types of applications. And don't get confused when I say types of applications in the class, students. Why? Because previously you have seen what? Static typed programming languages, high level programming languages, object oriented programming languages, procedure oriented programming languages. Next what? Robust programming languages. Next is called what? Come on. Functional programming languages, that is called procedure oriented only, that I will come across in the further. And today I'm going to say what? Unstructured programming languages, right? And structured programming languages. And today we are calling it as what? Process-based applications and thread-based applications. If you come to C language, for a minute you take, students, C language, if you take it, C language is called what? One of the static typed, procedure oriented, process-based, structured programming language. What is Python? Python is one of the high-level, object-oriented, procedure-oriented, come on, structured programming, thread-based application. Are you following? Where every characteristic I was explained so perfectly. What is this RPL I said? Robust programming language, even, because exception handling is there or not. So in every moment of it, there is a clarity is given. By seeing all these things, if you keep it, you can select what Python language is. Now I am entering into multi-threading in Python. What exactly this multi-threading is? Now I am going to give you the clarity. Okay, now? So let us start with multi-threading. In IT, I'll start from the beginning onwards. It is a new topic for you completely. We are understanding what is the importance of multi-threading. Right. In IT, even in Java also it is there. Even in .NET is also available. Even in any competitive programming languages also this is available. C language, no multi-threading. C++, there is no multi-threading is available. Okay. Right. Coming to the next, Java containing, Python contains, and C#.NET also contains. In information technology, we have two types of programming languages. Two types of programming languages. What they are? They are, carefully follow, students. One is called process-based programming languages. Process-based programming languages. B is called what? Thread-based programming languages. Thread-based programming languages. There are two types of applications are available. One is process-based and one more is called what? Thread-based. So I'll give you a small example because multi-threading directly understanding is difficult. That's why I will give you some small awareness for you. In process-based applications, take an example of it. Process-based application. All of you carefully listen. Take a meaning of process-based applications. What is happening in process-based application? Take an example, is a parent or is one human being. Is a human being. He want to do some 6 works. He want to do in a day, 6 works are there with him. 6 works are nothing but what? X function, Y function, Z function, and next is called a K function and a L function. Like that, one more function is available. Works means what? Operation to do it. Programmatically, how many operations can be done in where? Functions. You know that already, right? Now this person want to do 6 works. And how he will do it, these 6 works? He will start doing the operations. First with what? X. After completion of it, he will come to where? Y. After completion of that, you will come to where Z, you'll completion of it K, and then L, and then M, and other kind of works will be done. This type of working one after the other is called what? Sequential execution we can call. What execution it is? Sequential execution. That red line which I wrote it is the flow which is huge, which is concentrating on X performing, Y performing, Z performing. And this is K and L I am performing. The flow which is pointing and performing these operations is called what thread we can call. What is that? Thread is a terminology we are getting today. Suppose I came to the class. When I am teaching, I need to keep concentration or not. That internal concentration is called what? Thread. Getting? Now, suppose when you are eating ice cream, the taste you are enjoying internally is called what? Is called one thread. The way which you are going to be talking on in the phone with your friend is called what? The internal mechanism which is going on and concentrating on your discussion is called what? A thread. So, in process-based applications, if multiple operations are permitted, whose operation logic is written in the form of functions, if I start executing my functions, how these operations are performing, one after the other or all at once? One by one, this is getting executed. Such a type of execution is known as what? Sequential execution we can call. Spell out. Execution. Sequential execution. Internally, execution is done with what? Thread. Now, one point I want to say. Your Python language is also called what? Your Python language is comes under what? Also one thread-based language. Java also comes under one thread-based language. Java, .NET also comes under one thread-based language. You take an example of C language, C++, you take it. How many functions I am having? 6 functions are there or 5 functions are there. How these functions are executing one by one or all at once? So that type of execution is known as what? Sequential execution we can call. Internally, each function is executed by what? One of the thread. Such a type of application, only one thread is available. Such a type of applications are called what? Process-based applications we can call. Don't take much time, students. Easy, understand. What is this execution is called? Sequential execution. What is sequential execution? Performing the operations one by one is called what? Sequential execution. In sequential execution, how many threads are there? One thread is there. It will take more time or less time? More time. That's why this is known as what? Heavyweight components we can call. Heavyweight components we can call. Heavyweight means what? More time is taking to complete the execution process. We call it as what? Heavyweight components. Tell me, if anybody asks you tomorrow what is process-based application, what is your answer? In process-based application, there exist what? How many threads? One thread is execute. One thread exists. How the flow will be? It is going to provide what? Sequential execution. That is one by one will be providing. Takes what type of execution time? More execution time will be taken. If it is taking 5 seconds, if it is taking 5 seconds, 5 seconds, 5 seconds, 6 5, how many? 30 seconds will take. More execution time. They are considered as what components? Heavyweight components. As on today, in the software industry, there are no process-based applications in the field of computer science. You take the domains called internet domain, you take it. What are all the languages and technologies are using in internet domain or by default belongs to thread-based applications? Are you following me? Even if we come to the operating system level also, even if we come to the operating system also, there is olden days we are having thread-based operating, process-based operating systems are available. Example is what? Windows 95, you take it. DOS-based old operating system, you take it. They are all called what? Process-based operating systems we can call. Nowadays OSs, nowadays applications, all the things are comes under what? Thread-based applications. Process-based applications usage is very, very less. Shall I move forward? So what did you understand about the process-based application? In process-based applications, operations will be continued one after the other. Takes what time? Sequential execution time. Take how much time? More execution time because of one by one operations. And next is called what? Provides only sequential execution. Unable to provide what? A different execution. What is that? I will come to that. And it takes more time. That's why they are called as heavyweight components we can call. Next, I'm talking about thread-based application. Coming to thread-based application, meaning I am telling thread-based application, you take it. There is a person, same example I am taking. There is a person, X, human being he is, having how many works? 6 works are there with him. And he is having 6 works are there. X function and Y function and Z function and next K function and L function and M function. These are the different functions are there. Earlier, how it is working, how they are executing earlier, one by one. But now it is executing. See, he is calling 6 friends. 6 friends he is calling. 6 friends are coming. 6 friends means what? 6 helpers are coming to him. That first person is allotted to this. Second person is allotted to that. And another person is also. All 6 friends are allotted to what? 6 functions here. Tell me, how much time earlier was taken to complete it? 30 seconds. Now, how many seconds it will take to complete? 5 seconds. These the friends which we are saying in the class for our general knowledge are called what? Threads we can call. What they are called? Threads. So he is a person, he created 6 threads are created. Why 6 threads are created? For achieving parallelism, for achieving concurrency, for achieving all at once. Is these people are executing all at once or one by one? All at once is executing. Any operation executing all at once is called what? Concurrent execution we can call. Spell out. Concurrent execution. Executing one by one is called what? Sequential execution. Executing all functions at once parallelly is called what? Concurrent execution or parallel programming or simultaneous execution we can call. Did you understand my point? Tell me, how many types of executions are there? 2 types. One is sequential execution, concurrent execution. Who will provide concurrent execution? Thread-based applications will provide. Sequential execution provided by what? Process-based applications. In thread-based applications, how many threads are there? Multiple threads are there. Where it is possible to create the threads? In Python it is possible. In Java it is possible. In C#.NET possible, because we are having what? A library in that. Modules are present. If we go to C language and C++, there is no such libraries present. In which languages? C and C++ languages does not contain the library for development of what? That's why they are just satisfied with what languages? Process-based applications. And Java, Python, C#.NET are comes under what? So with the thread-based applications, what you can get it? What is an advantage of concurrent execution? Taking less execution time. Taking what time? Less execution time. If you go to olden banking system, if 20 people want to get the money from the bank, every customer has to go to the bank. Every customer has to stand in the line to withdraw the money. But nowadays, what is happening? Anywhere else you can withdraw the money through ATMs and etc. What is that ATM concept is called? A distribution of the work for parallelism. What is that work can be done with? With the threads. One bank, SBI, can be accessed by how many people across the globe? Many number of people can access. What is that concept is called? Concurrency. There is sequentiality. One more is called what? Concurrency. Did you understand first of all? Right. Last and final. One more example for you. And you are the student in the class. You are the student. It is the best example for you, where you can catch me what is threading. You are sitting in the class. That is nothing but you are my Python program. Student is nothing but it is a Python program. It is. What are you doing in the class? You tell me, students. What are you doing? Are you listening the class or not? What is this is called? Listen is called one function. For listening is concerned, one separate flow is created or not? One separate flow is created. A flow is created, a separate flow created for listening the class. At the same time, a separate flow is created for respond. You are also responding when you say good morning, you are good morning also. So after that, no more answers are coming. That is different story, except girls. Right? This is for responding also what is created. There is a separate flow is created. Listening is not disturbing with respond, and respond is not disturbing with what? Listen. Listening and responding, are you taking one by one or both of them at a time? Come on. Both of them at a time. Listening morning, responding evening. Responding 7 o'clock, listening at 6 o'clock. No. Parallelly going on. At the same time, you are moving your head also. You are moving your head also. That is nothing but what? It is also going on. Listening, responding, moving the head, all of them are going on parallelly. And one more thing you are going to do what? You are observing what I am explaining on the board. You are seeing on the board also. Seeing on the board is called what? It is a flow. Is these things are going on parallelly or one by one? Parallelly. And you are taking breath also. Breathe also you are taking. This is also called what? One more flow is created. During listening, are you taking breath or not? So these are all called one by one or all at once? Taking breath first, listening, after listening, taking breath, garbage collector will collect away. So by default, human being mentality is working on one thing or multiple things. So the way the people are listening, a separate flow is created. The way the people are responding, the people are moving their head, the people who are observing on the screen, the people who are taking the breath, these are all multiple operations are going on in your brain. The multiple flows are called threads. Did you understand? What is a thread? A flow of control is called thread. A flow of control in a program is called what? Thread. Suppose you take me, what I am doing in the class, tell me. I am teaching my class, one flow is created. I am going to observe you. It is called one more type of flow of control. Who is sleeping, who is not responding, and all those things. And next is called what? I am writing on the screen while I am speaking. And next is called what? I am taking the breath, and next I am seeing the chat window messages. These are all going to be one by one or all at once. So our brain is called what? Thread-based application. Multi-threading I did not use so far. Don't add your own language. Thread-based application. Spell out once. Right. Thread-based applications developed by using a concept called multi-threading. Thread-based applications developed by a concept called multi-threading. So what is the multi-threading is used for? Developing thread-based application. What is an advantage of thread-based application? What you can get it with thread-based application? Concurrency achieved. So what is the ultimate aim of multi-threading? Concurrency. What is the advantage of concurrency? Less execution time. Less execution time. Are you able to follow? So the app you take Amazon. How many people can use Amazon across the universe? Many people can use simultaneously. What is that apps are containing? Thread-based application only permitted, right or not? Total internet is running on what? Thread-based applications only. Without thread-based technologies and thread-based applications, as on today, nothing is existing. Are you following, students? Now, when you are going on the bike, what are you doing? When you are last and final example, when you are going on the bike, there is one person, he is riding the bike, he is sitting on the bike. This is called a bike. And don't ask me, sir, which bike it is. He is going on the bike. This is called a bike. Going on the bike. What is that person is doing? Number one, watching the road. Watching the road or not? Number two is called increasing the speed. Number 2, 3 is called changing the gears if gears are there. Number one, watching the road. Number 2 is what? Increasing the speed. Number 3 is what? Changing the gears. And number 4 is called taking the breath. So in his brain, how many flows are there? 4. And meantime, phone also will come. Phone will come or not? He will open and he will speak in the phone also. And something seen left side nice, he will observe that also. Right side something seen nice, that also will observe. Back side something missing, that also you will observe. Right or not? And by creating this much of thing, something will happen. That is called what in our programming? Deadlock. To avoid this, we are going to apply the synchronization concept. Multi-threading, too much multi-threading is also drawback is there. Too much multi-threading will give you the drawbacks. To avoid that too much multi-threading, too much concurrency will give you collisions. To avoid these collisions, we'll go for what? Synchronization concept. That is coming from operating system. Are you following or not? When you are driving the car, we are seeing on the screen way now. When somebody is driving the car, so many operations doing, listening the songs, talking with the friend, changing the accelerator, gears and everything, increasing the speed. And next what? See mirrors, observing front end, etc. And some people, fashionable people. Yesterday only I watched it. One girl is driving the car at 8 o'clock. I have seen. That's why I'm example telling. Talking in the phone. There is Bluetooth is there in the car. It'll connect. Big sound is coming even out also. And at the same time, okay, this is a normal we used to see. And she is taking black cigarette also. She is taking black cigarette. I've seen it earlier when boys are taking. Girls taking first time I've seen it. Because the black means night time I did not see. Only that fire is there now. I've seen it. I was there and I seen it. What is this? So I seen that small snow is coming inside and I observed it. And she's a girl or boy also I observed it. The girl. Like that 2023 onwards something is going on. So how many flows she is applying? Multiple flows. So that girl mentality is what? Threading. So don't tell these examples in interview students. Now coming to the topic. As on today, which one is having more in demand in application development? Thread-based programming languages and process-based applications are old application development. I will show you today one good example how these thread-based programming languages are fastness and then slow. So who is fast in execution here? Thread-based applications. So thread-based applications contains what? Process-based applications contains how many threads? Single thread. Provides which execution? Sequential execution. Takes what time to execute? More time. But what about, and they are considered as what? Heavyweight components. In thread-based applications, how many threads are there? Multiple threads are there. What is the thread definition I told? Flow of control is called what? Thread. Why thread is created? Why thread is required? Thread is required to perform the operation parallelly. Listening the class, observing the class. All these operations are called functions only now. To perform the function, this you have to remember, because beginning only I want to tell this, but I cannot say. Beginning you don't know threading now. In our Python program, even I will show today class, that is only my motive. Every function executed by the thread only. Are you following? So functions are executed by what? Thread. How the thread is coming, I will show you in the class. So what is the purpose of thread? The purpose of thread is to perform the operation whose logic is written in the form of functions. Parallelly or one by one? Parallelly. So thread definition is different. Thread purpose is different. What is the definition of thread? Flow of control is called what? Thread. Surya Varma, now a time girls are like that, sir. Yes, 100%. So, అందరు కాదమ్మా, నేను అదే చెప్పేది. Not everybody. So, they are not 2023 girls, they are 2073 girls. In 2073, everybody will become like that. There is no doubt in that. Correct or not? When we were students, whether you believe it or not, when we go to the college, OU is a branded college for topmost university. There, when 60 students are there in our section BE, first year, there 45 boys will be there, 15 girls will be there. Whether you believe it or not, in first year, in second year, in third year, second year, nobody will speak to them. They won't speak and they won't speak. Nobody will speak to, no exchanging. Nowadays, how it is? It is different, right? So, next day, what? Third year, what will happen? Third year, they will speak most respectfully. So, in fourth year, what is happening? In fourth year, first semester, they will ask notes. And how the notes will be taken? Not seeing the head to head like that. Keeping the head in some side, they will keep the head in some, only notes, whether falling down or done, what will happen, don't know. So online students don't know what I am saying. So that is the system of girls that time. This time is, because by seeing that, I want to share with you. Yesterday when I am going at 8 o'clock, one girl is taking the book and beating that student in the backside. With the book she is beating. What is going on? I felt very much disappointed, you know. And how it is going on? Right? Like that. Let it be, students, no problem. And they won't wear the dressing style what people are going on now. Earlier dressing style is so I can say total culture of Indians are there in them only. Okay, students, come to the point, because if I speak, time is not sufficient for me. So finally, come to the point. What is the final thing? Go to one small example again. Of course, our classroom girls are very perfect. There is no doubt in that. Even this side or that side is there. After within few days, they will set right. There is no doubt in that. Because I am seeing in the demo sessions, when the students are coming, they will sit in the back side only. Backside. With the friends, they will come and sit with the backside only. In our class, local area, non-local area will be there. So we will follow Indian culture, Indian ethics with a high technical things. So good now? Good only now? Right. So let us start with, now I am giving some small example here. Take OS. Going to the place. Now I am going to say, coming to this, one example I will take it. This is the OS, students. This is the OS. Now you can catch me because of this thing. OS, you take it. Right. Coming to the point of it. Yes, sir. Surya Varma, exactly. So coming to the point of it, these are all called what? My different apps I am opening it. Different apps I am opening it, students. Observe now. So I am opening this many apps. So my OS is called Windows 10. What are the things I opened it? Python command prompt I opened. Next I opened, you know, PyCharm I opened it. PyCharm I opened it. Next I am opening something like Jupyter Notebook open. So something like this I am opening. And next is called I am opened Oracle database, I opened it. Next is called one type of Paint, I opened it. Next I am opening MySQL, I opened it. Next I opened one media player, I opened it. One media player I have opened it. And next is called I connected with what? Some server, WebLogic server also opened. these many number of what? Applications open. Are you following me? Then who is providing the services to all these kind of things? Who is providing? OS only will provide the services for everything or not? Then what did you understand about this? OS is providing services to all these apps when you are going to run parallelly. So this OS is providing what? Is this operations one by one or parallelly providing? Parallelly. That's why in OS level, we call it as what? Multi-threading, multitasking we can call. Spell out, students. Multitasking. Multitasking we can call. So what is multitasking? A single program is doing multiple operations is called what? Multitasking we can call. I hope you are following me. Such a multitasking concept. In the multitasking concept, what is happening? The way OS is providing the service to Python command prompt is called one flow. The way which is providing the service for what? What is next? PyCharm is called what? One flow. The way which is providing the services to this Jupyter notebook, the way which is providing the services to all these kind of things are called what? Flows. Are called flows. The way which is providing the services to every app when you opened it is called what? Thread. So in OS, how many number of threads are there? Multiple threads are there. Which thread is providing the services to the opened app? So is my OS is a single operating system or single task operating system or multitasking operating system? And each flow is called what? One thread. Is it completing early or taking more time? Early. That means it is taking less time. So here there is a threading word is there. In languages, multitasking is bring on the name of what? Multi-threading. Spell out once. Multi-threading. So multi-threading is an alternative name of what? Multitasking. It was carried on the name of multi-threading in Python, multi-threading in Java, multi-threading in where? .NET, C#.NET. It is carried on the name called what? Multi-threading for application development purpose. This is OS level, product level, and application development, what came into the picture? Multi-threading concept came into the picture. What is the aim of multitasking? Concurrency. Such a name is carried in the languages on the name of what? Multi-threading. What multi-threading will provide? Concurrency is provided. So what is the aim of multi-threading, everybody? To provide concurrency. So C++ languages are called what? Process-based. Provides what? Sequential execution. Thread-based applications provides what? Concurrent execution. Takes what time? Less time. So what is the use of multi-threading? Multi-threading languages provides concurrency. What is meant by concurrency? Performing all the operations parallelly, simultaneously. Who will perform the operation parallelly? Thread. Multiple threads are there in the Python program. It is known as what? Multi-threaded program. Shall I move forward? Now, let me take one small example, student. Next, I am going to introduce one small diagram again. Online students, did you understand up to here? Come on. Is it understandable, students, all of you? This type of multi-thread. I am entering into the programmatically very shortly by seeing some more diagrams here. You coming to the environment of C programming. You coming to the environment of C programming once. I'm just writing one small diagrammatic representation. This is called what? Process-based applications we can call. In that, what are my functions available? For example, sum function. Next is called a sub function. Next is called a multiplication function. Next is called a div function. Next is called a modulus function. How these threads are executing? How the threads are executing? One by one or all at once? One by one. So first the sum function is executed. I'll show the flow also today. How the sub function is executing. After that it is coming here. After that it is coming to multiplication. After multiplication it is coming to where? Division. After division, it is coming to where? Modulus. This is the flow, how it is going to be executed. This is the flow, how it is going to be executed. How many flows are available? How many flows are available? Single flow is available. Single thread is available. It will provide what execution? Which execution? Sequential execution. Which execution, students? Sequential execution is provided. Such a type of execution is called sequential execution, we can call. And it takes what? Lot of time. Following me? Now I am going to come to the Python execution environment. I will come. Be careful, students. Python execution environment. I'll show all these things programmatically. Within very shortly, I'll show the coding. Coding part I will say. That's why carefully try to understand. This is called two environments I'm going to show students. Inside of it, this is a Python execution environment I am taking. Very shortly, try to follow. Python programming execution, Python programming execution environment. Python programming execution environment. Now, in this, we are having two things. What is the first one? Default environment. This is first one is called what? Default environment. By default, Python environment, programmatic environment, I want to tell you. Default environment in default environment. Look at default environment in Python. And the next is called programmatic environment. Programmatic environment. Both of them I am going to show you. Programmatic environment I am going to show you. Default environment use look at. Same to same. I will take the function sum, and the next is called sub, and next is called mul, and next is called modulus, and next is called division, and next is called exp, exponentiation. Who is going to execute our Python? Who is going to execute our Python program? Come on. Who will execute? PVM will execute the Python program. All of you know that once the Python program you are executing, who is the component coming first? Which component will come first? PVM. Who is going to compile our Python program? Python compiler. Python compiler. Beginning only I told you. Python compiler converts the source code into where? Bytecode. And bytecode is converted into executable code by the PVM itself. Now, coming to the point back, here I am going to say, the moment when Python program execution started, PVM comes into picture. The PVM internally creates one thread. PVM internally creates one thread. PVM internally creates one thread. You carefully follow, students. PVM internally creates one thread. This is very important, which I am going to show you that. So inside the PVM, what is there? One thread is there. That thread is responsible to execute our function. The same thread is continued with what? Is continued with what? Sub function. The same thing will be continued with what? MUL. The same thing will be continued with what? Modulus. The same thing will be continued with a division also. The same thing will be continued with what? Exponentiation also. Finally, I am going to conclude my sentences. PVM is containing one thread internally. I will show you the code also. That thread only will execute all my functions one by one. Such a type of thread by default PVM is creating, whose name is called what? Main thread. M capital. What is the name of it? Main thread. How many threads are there by default environment? Default environment contains what thread? Single thread is available. So default environment Python also provides which execution? Sequential execution. Sequential execution. I will show you that coding today. Sequential execution will be provided because only one thread is executing all those things. It takes what execution, students? More execution time is taken. How do you avoid this kind of thing? How do you get more execution, fastest execution? Same to same if you come, same to same if you come. I am taking some function here, next a sub function here, next a multiplication function here, next a modulus function here, next a div function here, next is called expo function here. Here what is happening? As usual, PVM starts executing. The moment when PVM starts executing, what is happening? What is happening? Internally, one thread is created. What is the thread name? What is the thread name? I told you, students. Main thread. Main thread will create. Main thread will create. The main thread internally, with the help of the programmer will create what? Programmer will create a separate flow of control for executing sum, separate flow of control for mul, and separate control for modulus, separate flow of control for division, separate flow of control for what? Exponentiation. This type of threading will be, this type of threads will be provided. Ultimately, I'm going to give my conclusion. What is this multiple lines? I wrote it diagrammatically. If you follow me, these multiple lines are called what? Threads we can call. All the students in the online, try to respond it. Don't sit quiet and calm. These are called what? T1. Next is called T2. Next is called T3. I'll say T3. And next is called T4. T4. Next, I'm going to say here T5. T5. I'm going to say T5. And next is called T6. This is called T6. T6. What is this T6, T3, T5, etc. are called? Subthreads we can call. Spell out. Subthreads, also called as what? Child thread we can call. Spell out. So in this Python program, programmatic environment, you see, students, programmatic environment, you see, how many threads are there? How many threads are there? 2 threads are available. One is called which thread? Main thread is available. Second category of threads are what? Subthreads are available. This is called which environment? Programmatic environment. So programmatic environment contains how many threads? 2 types of threads will be present. One is called what? One single main thread and multiple subthreads or child thread. Why multiple subthreads are required? To execute multiple operations. Tell me overall picture now. Observe both the environment. One is a default environment. Default environment contains how many threads? Single thread. Will provide which execution? Sequential execution. Programmatic environment contains how many threads? 2 types. One is called what? A main thread, and one more is called a subthread. Who will create main thread? PVM. Subthreads are created by programmer, which are internally monitored by what? Main thread. All the subthreads are under the control of which thread? Main thread. Are you getting the awareness? I'll show the same coding in the class also. So overall picture is what? When I start my program execution, who will come into picture? PVM. PVM will initiate what? Thread. You are simple. PVM contains internally what? Thread. What is its name? Main thread. I'll show the same thing. Simple, students. When you are writing the notes, you are writing the notes with what? Come on. Pen. Actually, that is the wrong answer. You are not writing with pen. In the pen, there is a refill is there. Are you writing with pen or refill? Refill. That refill is called what? Thread. That pen structure is called what? PVM. I hope you understood this. So keep that in the background of your mind and try to answer it. When the program execution starts, what you are doing with? PVM will come. When I say write the notes, what you are opening with? Refill or pen now? Pen. In the pen, what is there? Refill starts working. That refill is called what? Thread inside the PVM. You just think like your pen. Did you understand that? So now PVM contains how many threads by default? Only one thread. What is its name? main thread. Internally, later I will create my own threads. They are called sub-threads. How many sub-threads? If I have 6 operations, 6 threads. If I have 3 operations, 3 threads. If no more operation, 1 thread is enough. So by default, how many threads are there in Python program? 1 thread is there. What is its name? Programmatically, how many threads are there? 2 threads. One is main thread, sub-thread. What is the only default environment? Main thread will do what? Main thread will execute all the functions present in the program. When functions are there, definitely main program also will write or not. So main program statements will execute by main thread. Functions also will be executed by what? Main thread. Because only one thread it will execute all of them. But when you come to what? Programmatic environment, main thread will execute only what? Main program statements. Subprograms, that is called functions, are executed by what? Subthreads. This is the point. Earlier, your functions also executed, main program entries also executed by which thread? Main thread only. But here, in the programmatic environment, main thread is executed by what? Main thread is executing what? Main program statements only and monitoring the execution status of subthreads. But here subthreads are doing what? Executing all the functions. Simple, students. Your parent you see, and some childs are there. Child will do the original operation and parent is monitoring how he is doing. Are you following? If no child is available, parent only will do all the operations. Are you following me? So coming to the point back, now I am going to conclude my sentences. What is the main thread? What is the subthread? Can you repeat me once? Main thread is used for executing the main program entries plus subprogram entries. That is the functions entries. That is the default environment. When you come to programmatic environment, 2 threads are there. One is the main thread, subthread. What is the main thread is doing when it is a programmatic environment? It will execute only main program entries. It will not execute functions. To execute functions parallelly, what should I create? Subthreads I will create. So who will execute functions in programmatic environment? Subthreads. What main thread will do? Monitoring the execution status of subthreads, plus it will execute the main program entries. So are they called parallelism or not? So parallelism is achieved by using what? Threads. Shall I move forward? So the total internet world, even in our mobile, when you are talking to your friend, you can watch a game also now. You know better than me, that is. While you are going to do, while you are talking to a friend, you are also chatting with. That is also called what? 2 operations are going on at the same time. One flow created for talking, one more flow created for chatting. It is nothing but what? Both operations are going on. So your mobile apps are providing what? Multiple flows. That multiple flows are called what? Multiple threads. Internally, OS is observing also. OS is called what? Main thread. Our multiple flows, what the end user is doing is called what? Subthreads and main thread only. Now I am coming to the programmatic point. Please look at, students. Instead of typing the documentation work, I will take the help of something here. So see this now. I'll take these threads here. Now I am taking a small introduction I want to show you. A small introductory part I want to bring it here. So observe it here. Threads are there. Threads, I will take here threads. There I will try to take up. Now try to observe it. I am going to give you types of applications in multi-threading. Just try to follow. Read out. The main purpose of multi-threading is that to provide a concurrent execution or simultaneous execution or parallel processing. That is, parallel processing means executing all at once. In industry, we have 2 types of applications or languages. They are process-based applications, thread-based applications. In process-based applications contains a single thread, sequential execution, more execution time, heavyweight components, example CCPP. Thread-based applications contains by default a single thread. By default, I am saying, observe it, by default. And programmatically can create multiple threads. Diagram also you have seen. Thread-based applications provides both sequential execution and concurrent execution. Why? Default plus programmatic. Thread-based applications takes what? Less execution time. Thread-based applications are treated as a lightweight components. These are the languages of thread-based. Getting my point? Now, what is our basic goal today? Thread-based applications is our basic goal. Now I am entering into thread-based applications. So I am going to enter. Please look at that thread-based application. Please read out. Now I will go to the programmatic environment. The purpose of threading, I wrote once again same. Concurrent execution is nothing but executing operations all at once. The advantage of concurrent execution is that taking less time. If a Python program contains multiple threads, then it is called a multi-threading program. Definition of thread. Come on, students. A flow of control is called what? Thread. Next. The purpose of thread is that to perform certain operation whose logic developed in functions or methods concurrently. Multi-threading with OOPS also I will explain. Multi-threading with functional programming also I will explain. By default, every Python program contains single thread and whose name is main thread, and it provides sequential execution. Programmatically, in a Python program, we can create multiple sub or child threads, and whose purpose is that to execute operations whose logic is written in the form of functions or methods. Did you understand? Right. Students in online, is it Prashant, you are having audio problem. Now audible, okay. Now see that programmatically, how many threads? 2 threads. 2 threads. Default 1 thread. Programmatically 2 threads. Hence, programmatically a Python program contains 2 threads. One is a main thread, one more is sub or child thread. A main thread is created or initiated by PVM when program execution starts, and whose role, the role of main thread is to execute main program statements and monitor the execution status of subthreads if subthreads presents. If subthread presents. Subthread purpose, sub or child thread always executes operations whose logic is written in functions or methods concurrently. Are you following me? So now I want to go for showing one example first. First of all, I want to show you one example. What is the main thread? Whether the thread is there or not. Students in online, can you please confirm these 2 things? Types of applications is one thing, and next is called understanding what is the thread-based application. Online students, please confirm it. Don't become tired. Try to answer my question. Now, coming to the point back, now I'm going to show you the execution process. Go for Python program. Now I am taking here thread example 1.py. First time you are seeing. Today always we understand so far every program, every statement in the program is executed by one thread only, I said. Because PVM executes the program, I said. But inside the PVM, who is there? Come on, thread is there. What is the thread name? Main thread. Let me show you. Print name of default name of thread. Default name of thread. Today, don't worry. You just observe only this type of outputs you see. That's all. Outputs you see. I am writing double quotes, comma, threading dot, current thread, current underscore thread, dot name. You don't worry about what I am saying. Import threading. Are you able to follow? Import threading. What is the threading? Is the module for development of thread-based application. As we have seen that pandas, NumPy, OS, CSV, Pickle, like that, no? Like that module is called threading. Threading is a predefined module of Python language only. You see what is printed. There is no hurry at all. Nothing is difficult. You go for that. So I'm going to say threads. You save this code. Coming to that, coming to this now. So I go for what? Here, D colon. I'll go for this now. Python 7 a.m. threads. Sorry, threads. Now see the students execute. Py. Our program name is called what? Thread example1.py. What the answer is printed? Main thread. That means every Python program by default contains what? One thread. Right or not? Even you are sleeping, even you are wake up, some thread is going on from day 1 onwards up to 99 plus 1 years. What is that thread? Breathing thread. Heartbeat, that is called breathing thread. That is called one thing is going on. You come to the point back. One more point I want to say. This main thread, I will write it here. This main thread. This is a main thread is printed. Following me? Next. Second example you see. Second example. Now, I'm saying thread example 2.py. See students, def function 1, say pass. Function 2, def function 2, say pass. For def function 3, say pass. I'm just saying like this. Now I will write what here? Main program. Main program. See the flow. What I said, by default I am showing now. By default. Coming to this function 1, what I am doing? Print off. I'm saying simple one line. For indentation, you need to take it. Simple one line I am taking. There I am taking. I am from FUN1. And this is the end of it. This is the definition. I am function 1 executed by, I will write this sentence. Every function is executed by one thread, I told you. That I want to show you. Executed by, I will write it. Dot format of, you don't worry about what I am writing, my dear students. Threading dot, it is my explanation in tomorrow class. Today I am not going to explain anything related to the module name. Today I am showing what is the use of multi-threading. Current thread dot name. So done. Same thing. One more bracket is required. Yeah. One more kind of thing I will take it. What is the next one I am taking? Observe it. I am taking function 2. Same statement I wrote it. Function 3. Also I wrote the same thing. Function 3. Executed by this. Now this is called what here? Line number 4, right or not? Is it a line number 4 or not? This is called a line number 4. It's only for your understanding purpose I am saying. Other than that, nothing is there with this example. So here I am writing line number 9. This I am writing line number what? 14. Line number 14. Are you okay? Main program you come. What is the main program I am saying? I say print of program execution started. Program execution started. This is the one. Please be careful, mom. I say some 50. After that, what are you calling? Print the name of the thread. Print of. What is that now? Default name I am saying. Default name of thread. Please take care. Line number 20. Line number 20. What is the default name of the thread I want to say? Comma. I want to say threading dot current thread dot name I am saying. Threading dot current thread dot name I am saying. Close. After that, you see FUN1 calling, FUN2 calling, FUN3 calling, See students, line number for your better understanding, that's all. Line number 22. Line number, next is called what? 24. Why I wrote the line numbers? Why I wrote the line numbers? Because how the flow is. Now take care, all of you. Program execution starts from which line? 18th line. From 18th line to next what? 19th line. Line number 20. What is the thread name printed? Main thread. Okay. Function line number 21. Main thread will go from line number 21 to where? Function definition. Line number 4 is executing. Who is printing? Main thread only. After that, it will come to where? Which line? Line number 22. Line number 22 to 23. 23 it will go to where again? Function number 2. Line number 9 is executed. Main thread only. It will come to line number 24. 24 to where again? 23. It is executed by which? How many threads? Only single thread is executing all my things. Is it taking more time or not? Now execute it, and observe this. So coming to the point back, execute this now. See this entire flow. PY. See this now. What is happening? Import threading is required. Import threading is required, students. Import threading. And now execute it. See students, how it is coming. Program execution started. Line number 20, main thread. It went to line number 4, main thread. Line number 22, function 2 also main thread. Function 4 also main thread. What is this environment? What is this environment, students? Default environment. In default environment, what is happening? Main thread only will execute all the functions. Correct or not? Main thread only will execute all the functions. That will take what time? More time. One more example. Online students. Default environment. Main thread will execute. Main thread only will execute all functions. All functions. Takes what time? More time. One more beautiful example. Very shortly, I'm coming to this. Thread example 3.py. Thread example 3.py. Online students, I hope you are following me. One more example. 3.py. 3.py. Now I'm taking. What is that? D of squares. Squares of sepas. Next, D of cubes. Of what? Pass. To take an example, Gmail is only one thing, but many people connected to that or not. Everybody getting their own result. That means how many threads internally Gmail will create? Depends on number of requests are coming. Each request will be taken as one thread only. Coming to the point back, come to main program. I am measuring with execution today. LST is equal to, here I will write it. Print of program execution started. Program execution started by, I am writing, comma, threading dot, current underscore thread dot what? Name. What is the meaning of it? Least bother about students. Least bother about it. LST is equal to some 12 comma 6 comma 17 comma minus 4 comma 15 comma some 25 like this. I am having the data list. For this list of numbers, I want to calculate the squares and cubes. Squares and cubes. What I will do? Tell me. What is this now? Squares of what is the one I am passing? LST. What is it? Is it a function call or not? Which one will go to the function call? Main thread only will go to this function call. What should I do? Print it. Come on, how do you print it? For value in where? LST. Here I'll take the parameter or not? LST. I will say print. What is that? I'll print the name of the thread. I'll take what here? Square of this is equal to like this, dot format of threading dot current underscore thread dot name comma val star star 2. Mind blowing. Is it understandable? You are saying we crossed a different programming styles. This will give you what? Thread name, value will come, and square will be coming. And this value I want to print with some gap of that, sleep of 1 second, value by value, slowly, because you need to understand now. That's why I will import what here, threading, comma, what time. Already time related kind of thing. We already discussed the same line in where reloading the module time. Reloading module time, I was introduced to that. Okay. Similarly, same type of thing, I will pass it to LST here. You say this and write it. Value in LST, what I am saying now, cube I am saying, here I am writing value, comma, what is this now? Star star 3. Tell me this now. I'm going to say function call. I'm going to say what here? Cubes. Cubes of what is this LST? Now you take some type of what? Small line for separation and to see that cubes and small things. Are you following? Are you getting? So I'm going to take up here. After this, who is executing squares function? Main thread. Who is executing cubes function also? Main thread. Main program entry is also executed by what? Main thread. So total 3 parts are executed by main thread only. Is it taking more time or less time? More time. How do you measure that? I will take it. I will record the beginning time and ending time. How many minutes I take on the class? How can I know that? Beginning time recording, ending time recording, difference will give you the execution time or not. BT is equal to beginning time is equal to time is a function, which is a time is a module in the time function is there, which will record the milliseconds difference also it will maintain. Beginning time I recorded. At the ending time also I am saying ET is equal to what? Time dot time. Time dot time. Now you see print of what? Total execution time. Total execution time. This is a more meaningful example, students. Total execution time. With the threads or without threads are here. Do you have any subthreads? No. Total execution time in where? Default environment is equal to dot format of what? ET minus BT. ET minus BT. Are you understanding, students? Right. So this is the scenario of your program of what? Non-threading application. No threads are created. Default thread only we are using. What is the default thread now? What is the default thread now? Main thread. What is the thread name printed here? Default thread, main thread only. Execute. Huh? So line number 15. So line number 15, what is happening? Current thread off. Okay. Right, done. Execute it, students, and see that. Carefully follow. What is this example? 3.py. 3.py. Carefully try to follow. Program execution started. Main thread, squares are coming. Next after that, cubes are started. Now you see the ending time also I will give you. You see that. What is the execution time here? 14.06 seconds are taken. Are you following? Program execution started. Program execution started. Program execution started. Is now I am going to show you finally one more. Last and finally. And this is clearly I am going to show you how this execution is going on one by one. Why I put the sleeping time here? Because you have to observe it. That's why I said. This is going to be happening like that. Main thread only printed 14.08 seconds it is taking. This is called which example? With the threads or without threads? Without threads. So that means only default thread is available. Got it? Same program. Online students, did you understand? Same program. I am taking file and then say others and I am saying Python here. Now I am saying now. Go to this place, squares, so this I am going to eliminate. This I am going to eliminate. In this program, 4.py, with what here? With what here? Subthreads. Earlier one is what? Earlier one is what? Only with what? Only with main thread, without subthreads. Without subthreads. Here, with the main thread, and with what? Subthreads. A parent and children. A parent is sitting, children are doing the work fastly. Earlier, parent only doing everything. Now coming to the point, how I am going to do it? Up to here, same. Here you see, I am going to write it. That is what I am writing today, least bother. I am creating the subthread. How do you create? T1 is equal to threading dot thread of. What is the thread? Thread is a class in which type of module? Threading of. What is the T1? Subthread name. Is a kid, is a child one to the parent. Parent is telling to thread one, you are targeted to execute so and so function. You are targeted to execute X function. T2 is targeted to execute what? Y function. So I'm going to say target is equal to, target is one argument. What is my target? Squares. So easy, not a difficult. T1 target is to execute what? Squares. Don't call it as like that. Don't write. You say only function name. Comma. Args is equal to args. Args is equal to what is supposed to carry? One value supposed to carry that you need to pass in the form of tuple. You don't try to understand this coding. Just slowly, little bit you understand. 1% you understand. T1 is targeted to execute which function? By carrying which values? List of values. What is this called? What is this called? Creating what? Subthread. Creating subthread. Are you following me? Now I am going to say, you go for this place. T2 you take it. T2 you take it. E is called what here? Cubes. Cubes you take it. Target arcs is equal to what? Right. Creating what again? Subthread. What is the subthread object? T1. What is T1? Object. Whose name internally given by that as what? Thread 1. Internally PVM will assign to that thread is thread 1. Next is called what? Thread 2. What is thread 1? Name of what? T1. What is T1? Object name. What is this is called a name. What is T2? Object name. Whose name is what? Thread 2. Suppose if I take X also thread 1. Y also called what? Thread 2. Are you following? So they are targeted to what? So I will not call like that. I will not call. So T1 is targeted to execute what? Squares. T2 is targeted to execute what? Cubes. Now coming to the point of it, both of them are available. Here T1 is supposed to be targeted. T2 is supposed to be targeted. What should I do now? I should say both the threads are targeted. Now you have to tell them execute or not. You designed your threads to target of that and you go for what? You execute. To execute it, there is one function is there, T1 dot start. This I'll explain in tomorrow class. These lines don't worry today. Today I am showing that what advantages you will get with multi-threading. T2 dot what again? Start. Your parent said, go and do that work. Another child said, you go and do this work. Target is assigned or not? Now after that, what he will say? Start, he will say. Start means what? Go and do. Go and do, you will say. So start means what? You are going to do your operations or not? So start is the function which is used to dispatch your threads to execute the targeted functions. Tell me what is the thread is executing this one? Thread 1. Thread 1 is executing. Who is executing this? Thread 2. Don't expect and don't try to think like that. This thread 1 is doing its own job. This thread 2 doing its own job. Don't expect in the same order they are going to come. When you are going to withdraw the money in multiple ATMs, is the one person bothering about other person operation? Multiple people are doing their own operation on different terminals. Here also, different threads are doing different operations on multiple terminals. Okay, now we are supposed to understand the targeted time. Who will execute the main program thread, main program entries? Main thread. So here, for the simple thing, I will take one small thing. Right now, don't worry. I'm just saying this, you don't worry. T2.join, you don't worry. I said T1.join, T2.join, you least bother about it because I wrote something because I want to show you the timing here. Thread example 4.py. That's all. So don't call it as what? Any functions here. Main program entries are executed by which thread? Who will execute the squares? Thread 1. Who will execute this thread cubes? Thread 2. Thread 1, thread 2 are what? Names of subthread. What are the subthread objects? T1 and T2. What time is taking? That is the main important here. Execute 4.py. 4.py. Earlier one is called what? 14. Now you execute it. Now it is going to take thread 1, thread 2. You observe the flow. And don't ask me, sir, what will be the order of it? Right now, don't worry about that order. Right now, don't worry about the order means what I told you the example now. One ATM machine, different customers are doing different operation. Is one person is worrying about the order of other person? No. So what is the execution time now? What is an execution time earlier? So in a simple sentences, one can conclude that the sleep is not a matter here. Sleep is a matter for the understanding of the student. Are you following me? So one person of Gmail who is receiving the mail, another person who is sending the mail, never bother about the timing. What you are doing, there is no sequentiality. I will follow. So nobody will bother about the sequentiality of multiple Gmail users. So with the threading fast, you see main thread. It's a thread 1, thread 2, thread 1, thread 2. Is it giving the total time or not? So what is our total conclusion here? Thread-based applications are fast or process-based applications are fast? So fast. So here, the moment when you come to this point, T1 and T2 are called what? Creating subthreads. So this program is having how many threads totally? 2 threads. By default, how many threads are there? 1 thread is there. What is that now? Main thread. You see once printer. So initially total number of threads. Total number of threads is equal to, don't worry, I am writing something here. Threading dot active count. Tomorrow class I will explain this. Active count. Active count in the beginning will give you what? 1 only. Then when you start, when you go for this now, when you start now, after the threads are dispatched, what is this now? Now I will say total number of threads are how many? 3. Why 3? Why 3? One main thread plus 2 threads I created. After joining, you see, after joining, what is the thread? Now total number of threads are how many? 1 only. Why? 2 threads completed the execution now. Finally, how many threads are there? Right. Just to see the fun of this program once again. So see that total number of threads. What is happening? So something is there. Active count of function, that is active count of, say active count of, yeah, execute students. Active count how many? 1. Total number of threads now 3. Who is giving this active number of threads? Main thread. Total number of threads after completion. Why? Because middle they completed. They removed because operation is over. Those threads will be removed. And finally, how many threads are there? One. Beginning, how many? In middle, 3. At the end, 1. In middle, what is happening? The 2 threads which is completed, removed by the garbage collector by running its destructor, eliminating its memory space. This is called a keen of observation about what? Threading flow. So this example comes under for tomorrow's in detail. I will explain about what? Threading module and all those things. Today you need to understand only this part. This part. Up to here you understand. That's all. Tomorrow I'll go for the coding Threading I will discuss. How many number of approaches are there? I will discuss this entire thing. Later, day after tomorrow, I'll go for this part. Understood? So multi-threading will be fastest execution technique is achieved or not? Concurrency is achieved. Online students, I hope you understood. And tomorrow class, I'll go for what? Number of approaches for development of thread-based application and other kind of things. I will talk about that highlighted approach tomorrow class. Okay, na? Don't come late. Thank you. Read the notes and come. I will upload these parts in the class. Take care, students. All the best. Online students, you can hold on. If you have any doubts, I'll speak to you. Students in the online. So online students, if any doubts are there, can raise your hands.